Hello, everyone. Good evening. I believe I'm audible. It's been a long stretch over the month of June, and I'm glad that we're still here as the PDMP Tech Track. Today marks the final session on SQL, Structured Query Language. We've had an amazing time with our trainer, Mr. Gani Kuku, who is a data and analytic engineer. He has, over the past months, given us all he has and in a very simplified manner, too. And we don't take it for granted. So, ladies and gentlemen, for the final session, let's welcome Mr. Gani Kuku. Sir, the floor is yours.
Okay. Good evening, everyone. So we're going to be continuing our SQL class, our final class for the track. Okay, so I'll proceed to share my screen. So, okay. So I believe everyone can see my screen now. So today we are going to be looking at some advanced SQL concepts. So we'll be looking at subqueries, CTEs, Windows functions, and query optimizations. So we'll be starting with subqueries. So now, when you one thing that is important about this SQL language is that it's always better to know each concept instead of like cramming how to solve a particular problem. So it's better you are flexible with the concept, like you know each concept and what they do, than cramming a particular problem, because the world is advancing a lot. So nobody's expecting you to know the solution to that problem offhand immediately. But at the same time, your fundamentals should be strong. So when you decide to use artificial technology, even when the technology is hallucinating, you can still put it on the right track. Okay, you are making mistake or something like that. So it's very important as you proceed later on this journey. So we're starting with subquery. So basically, a subquery is a simple query inside another query. That's what subqueries just mean. Just a query inside another query. So maybe, for example, you are trying to answer a question and you need an answer before you can answer that question. That is when subqueries come in. We're going to try as much as possible to be fast so we can cover a lot today, because there are a lot of concepts in this final part. So I'll try to simplify it as possible, then maybe one example each or two. So as I said before, a subquery is a query inside another query. So when you want to answer a question, and before you can answer that question, you need to answer one other question. That is when subqueries comes in. For example, now you have a patient. Let's say for this database now, you have been asked to show, let's say, the patient who their healthcare expensive is higher than the average healthcare expenses. So now, before you can answer that question, you need to first find the average healthcare expenses first, before you can now show the patient whose healthcare expenses are higher than that. So that's the situation whereby what subqueries comes in. When you want to find values above or below the average, you want to find patients with the highest expenses, you want to compare one record with another calculated result. That is when what you use subqueries. Also, when you want to do equal to maximum or equal to minimum. So, and the syntax for subquery is generally, oh, sorry. So, subqueries follows this syntax. You use your select. Can you all see my screen? Please let's make this interactive like last class, so I don't want to be talking alone.
Yes.
So these are the syntax goal. It doesn't mean everything has to be like this, because it depends on the question you are asking, you are answering. So, but this is how it follows generally. The operator you want. You get all this in your slides. All those slides will be sent to you at the end of this class. So whatever information that want to follow, we follow. Then this can come in. So basically, it follows this syntax. This is the structure it follows. This is the structure it follows. So now, with the structure of the syntax, there are two queries. You can see one select from above, which is select column name from table name, where column name, then the operator, then select. Now, these are two queries, the first select and the second select. So that's why I said initially that subqueries when you what one query depends on what another query. By the definition, when you write one query inside what another query. So you can see these are two select queries here. So now these two queries has to run because one depends on each other. But the one that will run first what is the inner query, the one in the bracket, the select in the bracket. That is the one that will run first. So whatever question you're trying to answer, just know that the way it is structured is that the one in the bracket should come first because that one has to be answered before the main question outside can be answered. So let's look at an example now. Let's say we want to look for the example I gave before, the patient whose healthcare expenses are greater than the average healthcare expenses. So now we'll be using sorry, I have to open my Excel because I have to check the patient table. So let's look at the healthcare expenses. Is it here? Okay, we have healthcare expenses here. Yeah, definitely good. So we have healthcare expenses here. So we want to check, want to find patients whose healthcare expenses are greater than the what average healthcare expenses. Now, for us to get this patient, we have to first calculate the average healthcare expenses. This is where subqueries comes in. So let me leave this. So let's do this together. So we start with our select. Since we're looking for patients, it's important we put some of their details, like their first name. You can also put their last name. That is written there. First, last, first and last. Or if you just put the first name, there's no need of the last there. Let's put just the first. So what else will come again? No idea. Healthcare expense. Okay, let me do like this. I'm coming. So we can. Where are my active students? I'm not hearing people's voice today. What is happening?
We are here.
So we are here. We are trying to.
So this is the question we are.
What you are saying.
This is the question we are answering. I said subqueries is writing a query inside what another query. That's what subquery means. Simply a query inside another query. You're trying to answer a question. But before you can answer a question, you need to answer one question first. That is what's the basic logic behind subquery. So now it all depends on the question you want to answer. So I'm giving an example now is patient whose healthcare expenses are greater than the average healthcare expenses. That's what you want to answer. So before we can answer this question, we need two queries, the main query and the subquery. So before we can answer before we can get the patient, we have to calculate the average. So that's what we are trying to write now. So we're selecting first the first name. Let's go with the last name too. The last name. the healthcare expense from our patient table. Now, where that's our operator, as I said before. So you see the pattern. Select column name from table where the column name, then the operator will come in. So now, where healthcare, sorry. Now one's greater than. Now our subquery is coming in now. Select. I hope I've not made mistake with this my indentation. We are looking for average. So we are looking for what average healthcare expenses. From where? From our patient table. Okay. Let's run this. Let's see if there's not any error with our indentation. Good. Now have you seen our query results? So we can see our first name, our last name, and our what? Healthcare expenses. Now, automatically, the way subquery works is that this one in the bracket, this query here runs first in the background, calculate the average healthcare expenses from the patient before proceeding to what? To run this upper query. That is how subqueries work. So you could have many questions to ask. When you know that you need to answer one question before you can answer your main question, just know that subquery is what go-to syntax or concept that what you're going to use. So now let's move on to the next topic, which is
You are fast though.
yes, there's a lot of we can't if I keep on explaining subqueries, there's a lot. We still have a lot of functions to explain. So you will get the recording. So once you watch the recordings and you get the material, maybe extra research from your end, you will get it. There's nothing hard about it.
Okay, sorry. Can I still, just point out something?
Okay, go ahead.
Okay.
Can I hear you?
Where? Can you hear me?
Yeah, go ahead now.
Okay, so you said select this from patients where healthcare expenses is greater than. Okay, so it's greater than all these your subqueries now.
Yes, the logic is we're looking for patients whose healthcare expenses are greater than the average healthcare expenses. Now, subqueries comes in when you have questions you want to answer, but to answer that question, it depends on answering another question first. So to know the patients whose healthcare expenses are greater than the average healthcare expenses, you have to first calculate the average healthcare expenses, which is what we have done here. And as I said, the one in the bracket will run first. So now, after this one has run, it has calculated the average healthcare expenses, it has stored it in memory. Then it will now come now and pick the first name, pick the last name of the patients that are greater than this average that has calculated. That's why you're seeing greater than here.
Okay, it's because I'm seeing 6,172 cases as that. So I'm wondering, I don't know how many data we have. So
This
all
is the
these
out.
ones
This
is
is the
more
output is
than the
total
average. I know.
total total count of patients that have average healthcare greater than the average is 6,172
Our total number is what? Total number in the data.
in the
So
patient
this is
table.
above average, yes.
No, we're not
It-
looking at. Don't get me wrong. We're looking at the
I know,
average
I'm
of.
just saying the answer is kind of high. That's why I'm just wondering.
This is not the
Because
answer.
I know we're having 6,172 people
Rows. Yes,
uh,
yes,
as their distance is more than the average healthcare expenses.
yes,
An
yes,
average
yes.
is total divided by whatever number. So I'm just saying, unless our data is maximally high, having 6,100 and something
Yeah, the data
is
is a
to
large
me
data
it
set.
sounds
You have over
all right.
10,000
Okay,
rows in the data. So it's a
it's
large
all
data set,
right.
not a small data set. Okay, so let's go to CTE. CTE means common table expression. That's what CTE means. So basically, CTE is like a temporary result that we use to make complex query easier to read and understand. Let me put it that way. So just like a temporary result. So it's like a result that is like you're creating table as the name implies, common table expression. So it's like you are creating a table that only exists while the query is running. So for example, now you have a long query that you want to write. If you don't use T, it will be hard for you to understand the query because when you write it long, at the end of the day, you reading to interpret the query to be a difficult situation. So when you have a long query that you want to write, you break it down into chunks, into smaller parts. That is what CT is. That's when we use CT so that it will be easier to read. And your results, you can reuse it. You can easily debug than imagine writing 100 lines of queries that you want to use to answer a question. So instead of using that 100 line, you can break it into smaller line, maybe like 10, 15, 10, 15, 10, 15. So you can be able to understand it better. So anytime your query is becoming too long, just know you can go into using CTE. So now the general syntax for CTE is, I'm coming, let me clear this, is with whatever your CTE name you want to use as select your code. Now this is the very tough part of SQL or advanced part whereby you still have to do some effort from your own end. These are not just like the simple ones that we did before. These are tough parts whereby you have to put in extra effort from your side. So these are the CTE follows. So you can have let's say for example now from our patients, I'm coming. Let's say this is our patient table. Let's see. So we have 12,000 in our patient table. See, and just people that have values above the average is 6,000. You can see that it's not a bad result. That's what the data says. So now let's create a list of patients with high healthcare expenses. So let's say, how do we define high healthcare expenses? Anyone? How do we define something that is high healthcare expenses now? What value should we use to define high healthcare expenses?
Maybe above average now.
Okay.
Expenses above the average healthcare can be termed as high.
Okay, yes, statistically, I will agree with that. Statistically, you are right. Since it's above average, can assume is high. So that's another thing I used to tell people, my students, that don't just make assumptions if you cannot defend it statistically, except especially when you're dealing with numbers. You can have a case. There was a situation whereby a student was doing analysis and she has to she has to scale, and she didn't calculate the average of the column first before giving her scale. And majority of what she called high was actually low because they were below the average of the column. So it's also important that you do your statistics before you give assumptions, so you can have at least accurate figures. Though in some real case scenario, the business might determine what is average. Now, since we don't have any doctor here or any financial this thing here that is concerned with the data, we can assume that once it's above average, we can say it's okay as high. So now let's go to our postgre, and let me put the question here. Sorry. So when you are working in a more professional environment, always make sure that whatever query you are writing, you are commenting what that query is doing. So that's when somebody
Sorry,
comes.
if I may ask, you
Eh?
started this CTE. As in, if I may ask, I want to, why do you put us at that
That's
first row when you said with CTE underscore name? Why the us there?
now the as is part of the general syntax because it's going to take what is inside this query as the as an expression to answer the question. So it's part of the syntax. It's not just from anywhere. You have to put with CTE. That is CTE name. It could be any name you want to get it from. So we can say instead of CTE name now we can put we can say okay, let's write this query now. So we are following the syntax with. So now instead of CTE name, we're going to use high cost patients. So you can say high cost patients as now this as is a query that SQL is going to run that we want to answer. We want to create a list of patients with what high healthcare expenses. So now we're going to write the query to pick this the query that will answer this question inside this our bracket. You get? So we're picking it as this query now. So we're going to say as now the query that will answer this particular question. Select star from patients where the healthcare expense is greater than, let's see, greater than let's say 10,000. Let's say 5,000. Right? Now, don't forget I said it's like you're creating a what? You're creating a table. But this table is just available as the query is running. Based on the definition I said, you're creating a temporary table that exists only while the query is running. So we're saying with this is just a name. As this query that should run, now we now want to write the query that will give us the output of this table. So this is giving us the table, but it's not going to show us the output. So we're not going to take the output out, select star from, I want to use this changing of capital letter, small letter is what I don't want. I'm coming. Select. Now we have created a table which is what? High cost patients. So we're not just saying select staff from patients or anywhere. We're selecting staff from the table that has already been created, which is what? The high cost. So what happens in the background is that SQL has run the first query. It has created a table. Now, the other query here is to show us the output of that table that it has created, a temporal table, don't forget. So it just follows this syntax that I've written up here. With CTE as whatever question you want to answer, then select staff from whatever CTE you've created. Just as simple as that. So how long your query will be or how complex it will be depends on the question you want to answer. So let's run this and see. So we can see we have 12,000. So I guess all of them are even greater than 5,000. I'm coming. Let me check. Okay. This is okay. Not all of them are greater than 5,000. You see, I have 1,500. They don't all of them are greater than 5,000. This is 12,353. Okay, so you can see now from here, how do we validate as this figure is even this query is correct? Now, if you can see our total output here, it says 12,262. That is the total people that their healthcare expenses is greater than what? 5,000. Now, if you come to our Excel here, you can see that our total is 12,300 and what? 53. So we have like 100 people or less that their healthcare expenses is less than what? 5,000. So just know that when you just want to make your long query short and you want to break complex query into smaller ones, that's when you use CTEs. You can look at another example, like maybe let's say let's count our encounters. Yes, count encounters for each patient. So we're going to do this together. So how do we start? We want to count our encounter for each patient. How do we start? With what is the name? What do we name our table? We want to count our encounter for each patient. We want to know how many times the patient comes to the hospital for each patient.
Number of visits.
Number of visits, okay. Is that
No,
what
number of hospital visits. No.
You can just make it shorter. Number of visits. Okay. As is a constant. There's no way you can avoid this. Part of the syntax. You have to put your as there. So now, as what query will now give us this number of visits? That's what we are going to write now.
In parentheses, select.
Okay.
Asterisk.
Asterisk. Okay. I don't know whether it's wrong or right. I'm just following you. Okay.
From patients.
From patients. Okay. Okay.
Priska, continue.
It's not supposed to be from encounter.
From encounter, which one are you guys going for?
The visitation is not from encounter table. That one is.
Yes. Now, is there anything you tell me I'm writing? Whether it's right or wrong, I don't know yet.
No, I'm asking my class people now.
Okay, yes, it is account. Okay, I was thinking we have to select patients now before we now put encounter. The next one, where encounter. That's what I was thinking.
The question is count encounter for each patient. This is the question here. We are counting encounter, so we can't use a where clause here.
It is the place. I think it's even ideal that in encounter table it's not ID that is even that is showing us the number of time they come. I believe it's ID.
Yes.
It's in the role of ID that we have. I mean, as in they come on Monday, they register them. So far, I think I will prefer ID. Then we are
You are
no, I
counting.
mean,
It doesn't matter any column you pick. You're just counting the column.
mm, a busy day. It's brain. Okay, babe, continue now.
I'm just reasoning it out, Kita. Count, encounter.
Let me open the encounter PDF. I say PDF file.
Okay, please do.
See why I want to be fast, because this is just CTEs. Now we still have Windows functions to cover, and Windows functions are a lot.
Don't worry, you can be going after we read it. But maybe after I went through the last class, that join, I didn't finally get it. And the last part of that join, the left join and right join and all those, you didn't give us example. So you can, so that we'll have more time. You can be doing after we go through it. So we'll have time to have enough of those practical demonstrations.
Okay, so now let me answer this by myself. What's our time? So we have select. Selecting patients, because we want to count what each patient from the encounter table. So we are selecting patients. After we select patients, what do? We count. We want to count everything. That is star. What do you want to count it as? Whatever name you want to call it. So as you can say, total encounters. From where? From our encounter table. Now, if you stop here, we will not get to answer, because we want to count for each patient. So this one will just count the total encounter. It will not answer the question for each patient. Now, to answer the question for each patient, we have to group by. We have to group by what? The patient. Because when we group by the patient, it will now have to put what? Encounter for each patient. Then we can now, this is the query that answers our question. Then we can now proceed now to telling it to show us our output. Okay, I made a spelling error. Patients. Okay, sorry. So let's wait. Let me see. Is it patient or patients? Okay, it's patients, not S. No S there. Good. So you can see now. We have everybody coming outside. 12,330. Right? 12,330. This is the total encounter. We have people with 40, people that came 76 times, 100 and something times, like that. So Now let's go into Windows function. Now, Windows functions are very that much, but at the same time they're simple. So you just use Windows function where you are. That Windows function have several functions under it. Let me just say that Windows functions. So we have different of them. So they deal with rows. When you want to deal with rows, you want to evaluate your query based on rows, but at the same time you want those rows to be involved. You don't want the rows to how will I put it? You want the rows to be part of your answers. Let me put it that way. Let me look at the way I define it here. Okay, so now when you need row level details, that's when you use what? Windows function. You need row level details. Then there are several Windows functions. So that's the point. There are several ones. We have row number, we have rank des. We have several ones. So we'll just look at the ones we can look at. So let's start with row number. Let's start with row number. So row number is a window function used to assign unique number to every row. For every row in your data set, you want to assign a unique number. That's when you use what? Row number. That is what use the row number. So you can use to find the first record. You can use to remove duplicate rows. You can use to rank your record in others. So it's just like when you go to the bank and you line up and they start giving you people number. You're number 1, you're number 2, you're number 3, number 4, like that to the last person. That's how row number is. So the syntax is basically, I don't want to start typing all of them now. So the syntax is row number over partition. Okay, let me type it so that you guys can see. So just don't look as if I'm just talking. So we have row number. These are things you still have to go and practice after this. So if you know you really want to get good with this. So the partition by is a constant that does the division, the partitioning, the column name, then it follows by the order by. Then your column name. All these ones are the syntax are not they're not one big book. This does this general syntax. So the row number over partition by column name, order by column name. So let's say, for example, now want to count the number of encounters for each patient. Let's say we want to count the number of encounters for each patient. So let's say you can say select. I'll be going with small letters. You don't want to be changing coming up again. You can select our patients. You can select their what again? Patients, stop, start, provider. You can select their stats. This is what we want to select. So now the row number will come in. Once it changes, as the syntax follow over, you can put in your partition. Partition by what? Patients. What again? Can order it by when they started coming. So order by start, number of encounter for each patient. So we can call it as visit number. Then from our encounter table. Yes. Encounters. Yeah, I think this should work. Let me see any mistake from my indentation. Okay, let's run this. Let's see. Now, what our advice is, what you should know, what our advice you should know is this structure. Like I said in the beginning of the class, don't try and be cramming solution to answers, answers to question. And that situation whereby you use row number might not be the same question you want to answer. So when you know the structure of how row number goes, you don't have any problem cramming. You know this row number over, partition by, then order by, then whatever case you want to, whatever additional information you want to put, you put it in. So it's not as if you should now start cramming this particular query that answer this question and you want to replicate it for all the questions that you will later see in the future. No. The query is running. So you can see now. It's calculate, it has take the patient, it has take when they start. And what? Ish. And that visit number. So what this row number is doing now, you can see it. This our row number, this is the function here. Not this. This is what we've calculated here. In this start row number order by start as visit number. This is how it's bringing out the colon. So you can see 1, 2, 3. 1, 2, 3. So this one visited like 85 times. It's showing them the number of times they visit. So it's like it's repeating the rows. You know, the other one, it will just show the number of visits. This one now, you can see the patient is the same thing. 1, 2, 3. That means the patient came 3 times. It's preserving the row, the start date 1, 2, 3. Then the next person started from 1 again. It didn't say 4. So it's unique for individual patients. It's counting individual patients uniquely. So you can see it started from 1 again here. So he counted this one again till the end. Then started from 1 again for the next patient like that. That's why we're having 321,000 patients. So from this place now, you can say, okay, from here you can know the first visit to the hospital. This is when the person first visited the hospital. You can see this one now. This one changes. You can see this one is 2012. Still the same patient. But the next visit was the 7th visit was 2013. This one came again 2013. Just look down again. I mean, it's changed the 20. You can see 2013, 2014, like that. So that is row number for you. So let's look at another Windows function, which is rank. Yeah, rank is a very popular one. So what rank basically does is, that one is simple. To assign what? A rank or a position to each row. Just assign a position to each row. So for example, now you have let me use this. I'm coming. Let me do this. File. Blank public. So let's say for example, you have a runner, you have score, you have rank. I'm giving you an example. I want to use something simpler instead of that database so you can understand. C, D. Let's take for example now this. You have runners. So After they ran, they give them a score. So let's say, for example, this one had 98. This one had 95. Second person have what? 95 too. So now I have 90. Now, when you use rank we as a window function, we rank these runners. Now, how does rank works? How we rank? Will it be 1, 2, 3, 4? Is that how you rank it? We rank work like this?
No, it will not work like that.
Why?
The ranking will be according to the highest number. Like the score that is 98 will be 4. And it will go down like that.
So like this, 4, 3, 2,
3,
1.
2, 1. Yes.
Okay. Any other person?
I think B and C should share the same rank number.
Why? 1, 2,
Because
2, 3.
Something
Okay,
like that.
because
Just if you
the
want
same
to do
value.
it someday. But I think you also are liberty to do your ranking the way you want it, as long as you define it. That's talking from Excel.
Okay, now I'm talking about the ranking in SQL now, not Excel. When we use the rank function, like this, rank syntax, this is it. So now you are close. So rank will rank values. To rank based on values. That's how rank works. So now rank will do first. This is first position because it has the highest value, 98. Then there are 2 ties of 95 here. So rank will give them 2, second, like 2, 2. Now this third will not have, this 90 will not have 3. Rank will still have it in memory that there are 4 people. So this will give you 4. This is how rank works. So it is still stored in memory that it is 4 people that ran this race and 2 people took second. So it's not eliminating the total number of people that ran the race. So it will skip 3. Because why? 2 people are tied. So this is how rank works. Do you get now? So when you're trying to compare records, or you're trying to compare something based on their value, that's when you use rank. The value, very important. That's when what you use rank. So for example, now this is a leaderboard. When you want to create a leaderboard, use rank. You don't mind having gaps because you're having only 1, 2, 2, 4. There's no 3 here. That's when you use rank. So what is the general syntax for rank? Rank goes this way. Rank. Sorry, I'll be using small letter now because I don't want to be switching and pressing cap lock every time. Over. Rank over. Order by your column name. That's how syntax works. The syntax of rank. So for example, now we can ask, okay, based on our database, what do you want to use rank for? You can say you want to rank, let's see, organization by their revenue. Let's say you want to rank organization by revenue. We can say by revenue. So we can say select. I'm coming. Let me close this encounter. I don't want to open too many sheets. Select name. Okay. I have name here. Select name. How can we select again? Revenue, what is it called? Okay, we have revenue here already. Select name, revenue. Then we have selected what we want, the name and the revenue. What else? We want to rank. So you come in, rank over, right? Order by revenue, descending order. As revenue rank. From where? Organization table. Organizations. So you can see the highest is no, the highest revenue is health mark health, all mark health system. That's the rank of 1, 2, 3, 4, 5. So you can see like that. I don't think there's any tie here. So there it has ranked all of them. We have 5,000 organizations. So the first is health mark system. So that's how you use rank. So going on to the next one. But another important thing is if you know ties are important, use your rank. If you know ties are important, what? Use your rank. What is it called again? Always specify that it's from the highest to the lowest, which is the descending order here, DEX. Always specify this. So we have another Windows function, which
Okay,
is called,
please can I ask a question?
okay.
This indentation, are they a must or are they just your mannerism?
Yeah, it's not a must though. You can just my
Or
own is just to order it so that you can interpret it easily. But you can
it's
put
okay.
name, you can put name and revenue in this first line. Just make it like structure so that you can easily understand it. So that is it.
That's
So we have the next Windows function, which we call dense rank. Dense rank. Dense rank is our next Windows function. So now dense rank, what does it do? Same thing as rank. But instead of giving us 1, 2, 2, 4, what will it give us? Who can guess? Instead of 1, 2, 2, 4, what will dense rank give us?
1, 2, 2, 3.
Exactly. Excellent. It's give us what? 1, 2, 3. 1, 2, 2, 3. No missing number. So now this one is better when you want to look for like, I want to say like top something, maybe like top 3 provider, and their values are tied. You grab. So now it considers the fact that 95 and 95 are what? Tied. And 90 is what? The third. So it's intelligent enough to know that this 95 and 95 is the same thing. But we're looking for top 3. So we're not ignoring runner B or runner C. We're picking them as what? 1. That is the work of dense rank. So majorly used when you want to look for top 10, top 3, top 5, like that. So maybe you want to rank the hospital based on maybe it's revenue, but you don't want to skip any number like that. You want to be flexible enough that when you use your what? Your dense rank. So what is the syntax? Syntax is I won't be cleaning this. I'll just write the one for dense rank under for dense rank. The dense rank is the same thing. But the only thing that will change is that instead of rank, you put what? Dense rank. I don't want to waste much time on this. So we can change this one to, instead of rank now, we can change it to dense rank. So this is a long list, so initially, I don't even expect any type to be here. So this might not show the work like that, but still the same to show because there's no, why is showing like this? Because there's no tie in revenue. That's why it's showing like this. So that's that on rank and dense rank. So we have another one again. Lead or lead. How do you, where's my Excel? This is another SQL. So what does it do? It allows you to look at the next row. Just allow you to look at your next row without joining two tables together. So let's say, for example, now, let's say, okay, let's do like this. A patient came, let's say visit, and let's say dates. So let's say it came 1, it came 2, it came 3. Then on it came January, it came March, and it came what? June. So it can show you what your current visit and your what your next visit. The first time you came is January, then you came again March, then you came again what June. So you used to compare today record with what the next record. So let's say for example now, which example can I give? Oh, okay, let's say okay the syntax. Let's go to the SQL. Let's just say for example now we have okay. Let me give you the syntax first. Lead, the column name, then you have after the column name, you have, don't worry about all the syntax, everything will be sent to you in your material. All the material we've been using from the beginning will be sent by this night or tomorrow. Partition by column, order by column. Yeah. So this is the syntax. So let's say for example, want to take the patient, want to look at the start date and the next time they visit. So I don't know how to frame the question, but let's do it like this. Want to select the patient. Want to select the patient. You want to pick the stats when they came first. Sorry. Start. Then you want to know the patient, their first visit. Then this thing cannot come in. The leg cannot come in. Leg start. Then over partition by start. No, sorry, you cannot be partition by start. You be partition by patient. Partition by patients. Order by start. Order by start. As next visit. as next visit from encounters. I think this should be indexed too. Yeah. Let's do it like this. So you can see now. So you can see the first time this patient visited was in 2019. Now, you are seeing the next visit of this same patient was in 2020. Can you see? This is the last time the person visited. Now, if you look at one thing, you can see that the start, this particular one, they have the same dates. But now, the next time to visit is picking this. Can you see that this first visit is coming here as a start to the next visit? Now, this time here, the person did not visit again, so it was empty. So they went to the next patient. The first time this one will visit was 1985. The next visit was 1989. So you could see the past and the current. That's when you use lead. So you can see the current visit and the next visit. So that's when you use lead. So we also have another one again called lag. Lag. I won't be able to cover all of them. Maybe I'll just make mention of them and explain what they do. Not everything we're going to be writing query for. So lag is the opposite of lead. Lag, the opposite of lead. So instead of looking forward, as the word implies, it will work backward. So it compares today with yesterday, not today. You know, lead was today and next. Lag is today and yesterday, or today with yesterday. That's when you use what? That's why you use what? Lag. So the syntax also follows the same thing, but the lead will change to what? Lag instead of lead. You change this place to what? Lag. So lag or lead, anyone based on the situation. Then the next one is okay. Let's look at okay. That should be. I think that should be all for the Windows function. I want to explain for you guys. Lag and lead. Okay, so now going back to our join that we did in the last class that we didn't finish. I want us to use join to round up everything. Or yeah, was this we didn't finish all the join. So somebody was asking about the right join or something. Can you come up? I have to come in. Who was the person asking about join? No? We are going to be looking at some join concepts now. So I want to talk about why is this always having issue. The person is no longer online. Okay. So
I
now
think
I'm
he's
here.
Miss
I'm here.
Priska.
I muted, but he has finished his statement. Yes, I was saying that the join, the left join, right join, and all that, you didn't give us an application like how
we did
to.
the application now.
No, it's the
The lead
whiteboard.
that we
You
even
showed
spent.
us in the whiteboard, but we didn't do it in SQL. We only did
We
the
did.
intersection one.
We didn't do left join, right join. Are you sure? We did now.
Yes, as a query. No, we didn't do it. But you explained it to us on the board, but like how to query it and all that.
Okay. So now let me mention the menu I want to mention. We'll still come back to. So I've talked about right join, left join, uh, inner join, left anti join, right anti join. I think we talk about. So there's another one again, union. Union. So I think I mentioned union that day too. So union means when you're having two tables. Union. and you want to bring like everything together. Like when you want to combine the result of let me just put that way. You want to combine two
You called it a full something.
full join,
Full join, yeah.
full outer join. So now this union now, what it does is combine two or more select statements. Then it removes what? Duplicates. So for example, if you have patients, let's say there's patient 1 year, the name of the patient is 1, and you also have patient 1 year. You have patient 2 year, that is their name, not number. You have patient 2 year. So you have patient 3 year. You don't have patient 3 year, you have patient 4 year. When you do union will give you 1, 2, 3, then 4. It won't give you 1, 1, 2, 2, 3, 4. No, it will just give you 1, 2, 3, and 4. Not 1, 1, 2, 2, 3, 4. No. So that is union. So when you want to merge similar data from multiple queries, that's when you should use union. And you want to remove duplicates. You want to remove the duplicate automatically. That's when you should use union. Or that's why we use union. But they must return the same number of columns. They must return the same number of columns, and they must have the same data type. So the syntax, this one I have to, okay, let me write it. Syntax is a little bit long. So you have select your column name. Last class, we went far from our time. I don't want to repeat that again. Table. You have a table. You have selected your column name. Now you want to union it. Then you do the same thing again. Very simple. So instead of table 1, it now be what? Table 2. Simple. So let's say, for example, now, you have, let's say, you want to combine the patient from encounters and another table, let's say imaging studies. So let's just say imaging studies. So you can say select patients from encounter. Union select patients from imaging studies. Everything as one. Everything is coming outside as one. Because what? You are unioning the two tables together. Don't forget, it is patients you are picking from both tables. You cannot pick patients from encounter. Now you're going to pick ID from imaging studies. No. Will it work?
No, it's not supposed to work. No.
Why?
No, I want to make now. Without looking.
Because there must be a unique table between the two, or the unique column between the
Okay.
two.
Okay. I made mention of something. I'm not sure you people listening very well, but I want to ask this tricky question now. I will know whether you guys are following along or not. Dates. I'm changing some things though. I want to catch you people now. Procedures. Union. Let's say start. Start is from let's say start is an encounters, yeah. encounters. Will this query run? Will this query run? Will this line 49 to 47, will it run if I run it?
I think so.
Why will it run?
Am I correct first? Let me know whether my reason is.
Once I tell you are correct, that means you have
Yeah,
given
no.
you the answer.
Okay.
I want to know
Okay.
that you know why. That's when it's the why
Okay.
that will
My
make you
why
determine whether you
is
know it.
my why is if you select date. Date is like date in numeric.
Okay.
I don't know. Okay. Date is
Yeah.
he's going to go and pick the
State.
date from procedure, and then
Okay.
select start from encounter.
Okay.
And start is also a date. The
Excellent.
date
That's what I
they
want to hear.
started the thing. So it's kind of the same type
Yes,
of
it has
data.
the same data type. As I said it before. It only works when you have your columns will have the same data type. So now, once you see dates here and you see starts here, you might think, date is different from start. No, date and start are having the same data type, so it is going to work. Have you seen? Now let's look at our encounter table now. Where is it? Of course, encounter. Okay, let's look at another table here. Let's say first. Let's pick first from patients. And let's see whether it will work. Are you seeing? Automatically it's telling you first. Why? Because first and date, they are not the same data type. So when you are using union, always make sure that whatever columns you are picking, they have the same data type. So let's go to another one again. Union all. Union all is the same thing as union. The only thing is that it keeps what? Your duplicates. It's not going to remove duplicates. So you always use that when you know that every row matters. You want to show every row, every details matters. So you don't want to remove duplicates. Use your union all. So the next, intersect. Intersect. We all know what intersect is. This one come here. So come here. So that used to what? This is the intersect. That exists in what? In both record. What is the syntax? The same thing with the previous one. What we just change is that you change the space to intersect. Where is it? Instead of union, you put what? Let me just put them union all. Intersect. Still the same thing. That's how it works. So we have another one again, except. So except we return except we return rows from the first query that do not exist in the what? In the second query. So let's say, for example, now you have a patient that had encounter, but the patient never had an imaging study. So maybe that patient that would have encounter and have imaging study, or they have encounter and have immunization. So there are also patients that have encounter that does not have what? Immunization. So you can use that except to bring those patients out. So you use it to identify missing or unmatched records. So most especially we use this when we want to find differences between what? Two data sets. Use when you want to find differences between what? Two data sets. That's when you use your what? Except. What again?
Sorry, please, oh, maybe I got distracted. When you talked about union or,
Yeah.
can you please tell me what does it
Union
do
all is the same
again?
thing as union, but it's
Okay.
repeat duplicate.
All right.
Duplicate to show, but in union, there's no duplicate.
No
So
duplicates.
when you want to
Okay.
show every
Intercept
details,
is
including your duplicates, you use union or.
the intercept is what the two of them have in common only is what we show.
Yes, yes, Rose.
And
Yes.
except is the only the
What's
difference
in one
only.
place? Yes, difference between two data
Okay.
sets, you use it for that. So now,
All right.
with that, we go to another concept again, which is called views. View or views. Sorry, I'm not using my slide though. I don't know how to be reading from slides directly. Okay, so view or views. I know how you guys call this. So what is a view? A view is an SQL query and it's behaved like a table, but it's a virtual table. Let me put it that way. Yeah, it's a virtual table. A view is a what? It's a saved, okay. A view is a saved query that behaves like a virtual table. Now, when we mean virtual table, it means that virtual table, the data is not being stored. So it's like you are creating a shortcut to something. It doesn't exist in the memory. Let me put it that way. So, for example, now, maybe you work in an organization whereby they're asking you for a question, the same question like every day. So instead of you coming every day to be writing that same query, or maybe it's a long query, what you just do is just create a view. So once you create that view, anytime you need something from that view, you go there and pick it. Or you query the view anytime you need it. Let's say, for example, now you work in an hospital, they now ask you for the list of patients. Maybe your director or your manager comes in today. Mr. So and so, Mr. So and so, give me the list of encounters we have this morning or for the past day that they have for the last day. You gave them. Tomorrow comes again, they say, oh yeah, give you the encounter for the previous day. You give them. So you are repeating the same query every time, every time, every time, every time. So instead of writing it every day, what you just do is what? You create a view and you continue to use it. So now, what is the syntax? Let's come here. So the
Wait,
syntax of view is simple.
sir, do you mean like if I understand this view correctly, it's something like your clipboard in your phone where you save things that you copied, you can always refer to it.
Yeah, we can use that. We can use that logic. We can use that analogy too. We can use that analogy too. But don't worry, we are going to see it here. Don't worry. Don't worry. Just you will see what I'm saying here now. So the syntax is create view, whatever the view name you want to use, as then you can write your query based on the question you want to answer from. So whatever the question is, that is how you create your view. How do you query a view? To query a view, it's simple. It starts the same way. Select star from from view name. How do you delete a view? Simple too. Now watch, I'm going to do something now. Drop view, then the view name. This is how you do. So creating a view, create a view. Now look here. Now let's look at an example. Let's create a patient view. Let's say we want to get the want a patient summary. Let's say we want a patient summary now. A view for the patient summary. Instead of coming every day to be writing query for the manager of patient summary, you just create a view. So what do we do? Right, create view, patient summary, which is the view name. patient summary as now what to make up the patient summary. We have to select the patient ID, the first name or the last name. First name, okay, both of them. The last name, the gender. It could be any case as your question may be. You can put the birth date from where our patient table. Then we run. Now, where's our result? It said create view, query returns successful in 104 milliseconds. Now, where's our result? And we have 3,000, we have 300,000 rows. But where's our result? Anybody know where the result is? Where's our table?
I think on this side we'll have data output.
On where?
Uh,
Data output here?
yes.
No, it's not there. Who stole our table? Where is it? Now, as I said before, or as the concept is, I said it's a virtual table, right? It has been created. It is here. Where is it? This is it here. These are your views. You can see that Postgres specifically has what? A specific section for views. Now, we cannot see anything here because of what? We have not refreshed. You can see there's nothing here. But let's refresh. Can you see? This is our patient summary. Is what? Under what? Views. So when you create a view, it comes under what? Views. Not under what? Table. But we can still view this. So how can we view it? Select star from what? Patient summary. Simple. That's the views for you. So when you have something that you know that they will ask you today, they will ask you tomorrow, they will ask you next tomorrow, just create a view there. Anybody can come here and come and start using it. It's also work in Excel or any other system if it's not in SQL, whereby you have a database, but you are giving a particular set of people what they need to answer their own question. So maybe you are working in sales team. If you are working as a database administrator, now you cannot give everybody access to your entire database. When you have like sales department, you have a marketing department, you have finance, all those separate departments, but you are the database administrator that is in charge of everything. There's something we call secure row level based access security. So now what you can do is you can create a view for the sales department that will contain all the old columns that they will need for their analysis or for their whatever they want to use it for. You can create views for finance departments. You can create views for what? Marketing department. So nobody's intersecting with each other data. So everybody will go to their data and use what they want to use. So that's how views work. We have different type of views, but you can read on that on your own personally. So now, the next concept we look at is index. What is index? Based on just our normal English index. When do we use index? Anyone? Index or indexes. anyone you call it. This indexes. What is an index? What does it do? So basically, an index helps Postgre help us to find data faster. So imagine you go to the library, you have a textbook like an encyclopedia. Without the index, you want to check a particular thing. Once you go through the index and you see the number, okay, this particular topic is in page 220 something or chapter 200 something. What you just do is what you move there straight. You don't have to start going through chapter 1, chapter 2, chapter 3, and be checking each of them one by one. You just go through the index and what pick what you want. So index helps Postgre find data faster. So instead of you reading every row, it goes and directly to the row you need. So you just use index when you want to make your query faster. You have millions of records that is large, and you don't want to go scan through everything. So you use your index. Or when you frequently search for something, you also use your index. So what is the syntax for index? You have a create index, the index name, on the table name, and the column name. That is the syntax for index. For creating index. If you want to delete index, you just use your drop index, your index name. So first, say for example now, let's look at our patient table. Now let's create an index for our patient table. So we can create our index for our patient table, like our index ID. So we just use create index name. You can say index IDX patient. Let's just use that way. Let's say patient on patients. What column? Our ID column. Now, how do we view our index? Huh? How do you view our index? No answer. Okay. So
Maybe
now,
they may be index column. We run up and down. In
yeah,
the same way we have the view. I'm saying it's possible there is a section for index. Maybe the way we have view or something. I don't know.
there's no section for index. Yeah. So how do we create it? Okay. So now, next, take that as the assignment. How do you create index? Explain, analyze, or your research. So I talk about. I want to make sure we cover everything in the stuff. I talk about subqueries, CTEs, Windows function, index. Index is part of query optimization. So I have to mention that the index is part of your query optimization because it makes your query faster to get your results. So index is part of query optimization. Okay, let's look at analyze again. Analyze, explain, analyze, another SQL concept that's very important. We call it explain. Let me type it out. Analyze, like this. So what does it do? It explains and it was analyzed. It shows how the software, which is PostgreSQL, how it executes your query. This might not be something you use frequently, Might not be something, but it's worth knowing for intermediate level. So it's worth knowing. So it just help you answer questions like which table is read first, is Postgres using an index, how long the query took, something like that. So it's just like a diagnostic report, let me put it that way, for your query. Just like a diagnostic report for your query that you run. So it doesn't change your data, it just help you understand how the software itself is processing your query. That's what Explain does. So when do you use it? When you're working in a situation whereby you are saying that your query is taking time to run, everything is slow. So you now want to you decide to improve your query performance. You start to do like it's just as if you are doing a data analysis, query analysis on your query. So when you use Explain Analyze, you could easily see what is going on and see why or what is causing the slow performance and how you can optimize it. So Explain Analyze is simple. You just the syntax is Explain Analyze, select whatever you want to select from. Just like this. So let's take some simple one again. Let's say explain, then analyze, explain, analyze, then we say select star. So we're telling you to explain and analyze this particular query that we're running from patients. So we're saying you should explain and analyze select star from what? From patient. That's what we're telling you to do. So let's run this. Can you see? The cost 0.0000 blah blah blah. The rows 500 and 5,000. What is this rows? The okay 12 its cost is 0.00582 blah blah, very little. So as I mentioned before from our first or second class, that when you're working in production scenario whereby your query will be having you cost, avoid the use of select star. Pick only what you need. It is maybe you need only first name, you need age, you need gender from patient. Just select first name, patient, select first name, gender, age from patient. Don't do select star because it will query the entire table. Meanwhile, you just need 3 columns. So that will help you with cost optimization. So it has 12,352 rows. This is 270 while it took 0.0 something seconds to work. The planning time is execution time. That explain this query for you. Now, if you look at this figure now, let's save it. I've copied this now. Let me see. Did it copy? Let's paste it here. I want to check something. Did it work? Oh, it didn't work. It didn't work. I think we could. Supposed to be able to copy now. Okay, copy with headers. Why is it not working? I think it should work now. Oh, no. Good. So now let's look at this. So we want to look at something. So now we did select star from patients. Watch with me. Now let's do select. Let's do select. Where's patient? This patient, right? Let's do select first and marital. Let's do select first and marital. Let's do this two alone. Let's do this two alone and see. Now, can you see the difference? In a situation whereby they ask you to, you're working a production case. Now, can you see the time it took to execute the two queries? It took this one 0.81 milliseconds. It took this one, it took 0.81 milliseconds. This one, it took 2 seconds. Can you see the time difference? Are you people online or you people are sleeping?
I'm awake.
Okay, so
But
now
I'm not looking at as if this one you pasted now, the total execution time was now more. Second one is
yes,
2.74 milliseconds. Why? But it had few things to query.
yes,
So why?
it has. I don't know. Maybe that should be an error from that. That should be from the. It should not take more time than. Wait, I'm coming. Let me see whether. Let me run it again. It shouldn't take more time than. Okay, you see, it's changing. It's changing. So there's no maybe based on the server. You can see it's reducing itself again. So maybe it's based on the server that it took more time. But the planning time initially to show you that the planning time is changing. The execution time is just based on the server. It took lesser time to plan this query out, to organize the outputs and pick it up than this one. It took 2 milliseconds. This one it took 0.081 seconds. This execution time just based on the server. So explain analyze does not change your database. It only analyze your query. That's what it does. And the best thing you can do is you always run it before you run it, whereby if you are having a complex query you want to run. For example, now you can be brainstorming on a particular question and you have this query and this query you want to run on a production case, and you don't know which one will be faster or which one will benefit your company. Maybe this one will take more time, this one will take more resources. You can use your explain analyze, run it on the first query, run it on the second query, compare the outputs, then you can decide. So we also have the case. Case is another SQL syntax. It's used when you want to do conditional formatting or conditional logic. Let me put it that way. You can have when you want to say case when something like, how will I put it? When you want to, okay, let's say you want to categorize data. Let me put it that way. You want to categorize data. You want to simplify reports. You want to use maybe a business rule where a particular value is, if it's greater than 5, it should be. If it's greater than 5, it should be red. If it's greater than less than 5, it should be blue. Stuff like that. So that's when you use case. So the syntax, let me just put the syntax so you can see case when your condition, then your result. So it can take multiple case when again the condition, then your result, then final. Just like you're doing if else statements. Let me put it that way. Yes, that is just it in SQL. That's when you use case. Sorry. When you're doing if else in Excel, that is the same situation for case. So and your end must always be there. You must not miss this end. Very important. The keyword end must always be there when you're using case. So you also have another one again. Coalesce, how is it pronounced? Coalesce. So coalesce returns the first value that is not null. It always return the first value that is not null. That is what you use colis for. So let's say for our database now, you have patient table, you have death dates. So anybody that does not have death dates means what? The patient is still what? Is alive. So you can say, instead of showing what? Null, to show what? Alive. So you can use colis to replace null value. So instead of it to show null, you replace it to what? Alive. You grab. So with that, it makes results easier to understand. So and it prevents blank values from appearing in results. So when you use it, you know when your data contains missing value. That's when you use colis. So what's the syntax? Syntax is colis the value 1, the value 2, like that. So let's take, for example, now. As I said before, let's show patient status. You want to know whether they are dead. So you can say select first, last, colis, or qualis. What do you want to colis? Colis the death date, the death date is test. No, sorry. Death date should be a test. Yes, the test. A date. Let's try test first. Listen. Continue to what? Patient table. Let's run this. So all these people here now, they are what? All alive. See? Now all these people are saying alive. If I didn't put alive there to return null, that is the duty of colis. Colis is instead of bringing out null, bring out what? Alive. They're all null values. All these alive I are saying, I've replaced it. They're all nulls, but I've replaced it with what? Alive. You can also replace it with what? Living. The case may be. Also replace it with living. So you just use to what? Replace null values. So what I want to say again, I want to say something. Now colis and case, they're not the same thing. When you want to replace null values, that's when you use colis. Don't use case when you want to replace null value. Use case when you have what? Multiple condition. When you need multiple condition, case when this and this. Don't use null value with case. Only colis that works with what? Case. So we just use colis specifically for what? Avoiding nulls in our results. And you choose your replacement value by yourself. So what other function like null if? Null if is to compare two values. You can read on that. When you want to prevent division by 0, you use null if too. What other ones we have? So the syntax for null if is null if you have the expression you want to say expression 1, expression 2, like that. So we also have cast. So cast is just to store number as what test. To change one data type into another data type. That's what you use cast for. You can cast test to number. You can cast number to test. You can cast timestamp to date. You can also use it in performing calculation. So when you are doing, for example, now you are doing a calculation and you forgot your data type, maybe you forgot that a particular column, you record it as variable character instead of integer. So as you are going on, you now remember that, oh, this column is numeric instead of integer. You can just use cast instead of going back to alter your data type from your table. You can just use cast so it will work for that particular query. It's not going to change the entire data type, but just for that particular query, it's going to work. So you use cast column name, something like the syntax is cast column underscore name as what data type that you want. So it could be anything that you want to put. So you can cast as numeric, you can cast as integer, you can cast as date, as the case may be. So what do I want to talk about? Okay, you can go ahead and read about CTEs, multiple CTEs. You can go ahead and read about how you use CTEs and Windows function. You can go about nested query. Also, what we call nested query. You can read about that one. Nested query is a subquery inside another query again. You know we have subquery, but when you have subquery inside another subquery, that's what we call nested queries. So you can read that online. You can read about correlated subqueries. I always talk about type of views. You can read about the different type of views just for your own knowledge. We have simple views, we have complex views, we have materialized views, updatable views, we have different types. So you can read about all those ones on your own. So now, before I will just use a few minutes for what is it called? Somebody talk about what did we talk about? Somebody asked about right join and left join. Abi, what did she even ask about that time? I want to use
Yes,
just
yeah.
like 5 minutes.
The left join, right join.
So
What's
is
the
it that you
join
don't
join?
understand what they are, or what is the problem?
No, like we didn't do a practical. Like we did union now. Like
Yes.
how you set it and you did here and we see results. So the other one,
Okay.
like if I remember well, in the left join and there's one in the whiteboard, you said if you have A, B, C, D, and you now join, the other one has A, B, A, B, B. What will now have the letter will now be the A, B, C, D, E, and D, as C and whatever. But it's like I want to
Okay.
see for real how it's going to appear and how you now put the query, if that's
Okay.
what you're
So now,
interested in, and scenarios we can use it.
okay, let's say okay. But you know where left you know what left and right join is, right?
Yes, you explained.
Okay. Okay. So now let's look at something. Let's say let's start with left join. So how can I say, okay, let's look at the patients. Let's start with patients with encounters. Patients with encounters. That's what you want to bring out. So we want to bring out audio, we want to bring out the patients that are common in what? This is patient table. This is encounter table. So while we're bringing out audio patients in patient table, we want to bring out those patients who that appear in what? Encounter. That is your left join. So this is patients, this is encounter. And for us to do that, we have to know our what? Our primary key. We have patients here. Let me close this one. And our foreign key. So let me open encounters. I'm sorry for the extended time. Just let us just cover this left and right join. We can call it a day. Uh, Coming, it's loading. So for our patients, our primary key here is what? ID. I said in the class. On our encounter, this is our patient ID here. So this is the foreign key here. So what we will join on is our what? Patient. So we're joining on ID and patient because that is the common columns. This ID you are seeing here is not patient ID, it's encounter ID. So they're different. So let's come here now and run that kind of query. So we say select patient. So we say P, first name, select P, last, from where? From our patient table, which is P. Then we left join it with our encounters, which is what? E. Now, if we want to pick anything from encounter, it's simple. You can pick, where is it? Encounter. Let's pick no, I don't want to pick description. Description is a little bit long. Let's pick encounter class. Grab. So let's pick encounter class. Encounter class E. Right? I hope there underscore there. No underscore. Encounter class. Okay. So encounter class from patient, let's join on this. Okay, or let's pick, okay, E, encounter class on key.id, which is the primary key for the patient, equals to E dot patient, which is what? The foreign key for the encounter. So we can put it like this. But let's do where the encounter ID is null. Yeah, let's try this. Let's see. So these particular patients, they have what? They didn't have encounters. They're in the patient table, but what? They're not in the encounter table. They didn't have encounter class, sorry. So you can also do for organization without encounters. You can do encounters without imaging. This is just the structure. The columns you want to pick, your aliases that you use here. You can use anything. It might not be P, but best practices is that whatever your table name is, use the first letter. So these are the structure of how left join works, and for right join is the same thing. Just that you are picking in right join, you're not going from encounter to patient now. You're not going from patient to encounter, you're not going from encounter to patient. So you are picking this now, the right join. So you can twist it anyway. Because for example now, if you are working with Power BI, you could select anyone first. So if you put encounter here and you put patient here, you can interchange right join and left join. But in SQL, you have to state it explicitly because you are typing. It's not like Power BI, just drag and drop. So you have to state it whether it is a left join or a right join in SQL. So any questions again?
Okay, yes, please. Can you come back to the SQL?
Okay.
Okay, if you remove this query number 10, what will happen?
If we remove query number 10, nothing is going to happen.
As in, what will it give us?
Let's see.
What will be the interpretation of?
I did is null. Those that they don't have encounter class. That's what I did. Now, if I remove it, it means that one is just a condition. If I remove it, it gives us those that have encounters. The initial thing that we want. I just put where a conditional statement there, filter, where is ID is null. So it's not doesn't have any issue with it.
Okay, what I'm saying now is, like when we're giving these things, we'll be given in English language, like you told us. You have to figure, like now, when we do this left join, just selecting the things you want and joining the two of them together. In this table, is just giving me. Sorry, I'm using my phone. I don't know. It's giving me. Please, can you help me? Have 1,000. Okay, no, 32,000.
Okay, the output.
The interpretation of that table.
This one here.
As in, what for real is it giving me? Indication
This
of
patient
what?
with encounters.
As in this result now.
I pick, yes, this is the patient with the encounters that I'm saying now. But I just included the encounter class. I can decide to remove the encounter class. So this is the patient with encounter. This is the encounter they had. The encounter class they had, sorry.
Okay, maybe we'll go over it again. We'll understand better.
The thing is, there's no the way what you will select will be determined on the question you want to ask. But just know it follows this structure. You are selecting the columns you want to pick. If you are picking external multiple columns again from the other table, because two tables coming together, the logic is that there's something you want from table B that is not in table A. You grab. So you want to pick that thing, but based on this logic that you can join them together on their primary key and foreign key. It's like you're having two baskets. You're having apple and orange somewhere, and you're having pineapple and banana somewhere. But you need apple and orange, then you need the banana in the other basket. But because you have apple and apple in both baskets, you can come together and pick banana based on the fact that there's apple and apple in both. If there's no apple and apple in both, there's no way you can talk to second basket that have banana. That is what left join and right join is about. That is what join is about. So the primary key and the foreign key must exist for you to be able to communicate. So now I can pick anything again from. If you look at this encounter class, it's not a patient table. There's nothing like encounter class in patient table. This is it here. There's nothing like encounter class in patient table. But because of the information is in our encounter table, and I need it, but I can use my patient ID and the patient I have here to communicate and pick out this encounter class. That's why I use what? Join.
Okay. So when do we know when to use left join or right join?
Now, it depends on the question you want to answer. Now, as I said before, I want to know everything in my encounter in my patients that have encounter, and I want to pick what's the encounter. So I need to pick everything in patient and pick the patients that have encounter that appear in the patient table too, and the encounter table too. Sorry. So I need, based on the image, I need everything here. Sorry. I need everything here and everything here or things here that appear in this place too, which is the common. So I need everything. That's when you use left join. If it's the other way around, you use right join, where you need everything in the encounter, but there are some of them that appear in the patient table, then you use right join. If you need what appear alone between two tables, you use inner join. If you need the entire table joined together, use full outer join. So that is that one. If there's going to be a project for you guys to do, I will work on that and send to you, because I know the table, it contains a lot of tables. So I'm going to give you any project for you guys to do. If you want to do it, you do it. If you don't want to do it, fine. So I'll send that to the group, or I send it to one of the admins. So that will be all from my end. Thank you very much.
All right. Thank you very much, sir. I appreciate you.
Thank you very